Cache me outside. While being super relevant with my meme references, I wrote a program to see how much you understand heap allocations. Maybe helpful to read a little bit on glibc's TCACHE. So glibc's TCACHE is a per thread cache. So when you ask for a memory allocation, if you have one of those that you freed, you can sort of hand it over right away. And it's per thread so that you don't have to do a global lock. So it can give you some really fast allocations if you're reusing blocks of memory that you've used before. So here's a little bit from the source code for malloc and glibc. And you can see right here, there's this idea that we look through the bins and we can get something if we have a size that we've seen before. And so we've looked through this size. If we've got one, we can call this tcache get. We grab it. It's a singly linked list of these things that we've seen before. Okay, I've also downloaded the program that they've provided, and I've done some work here trying to make it a little more comprehensible in the main. I've added variable names and whatnot in Ghidra. So they open a flag file, and they've got this random string that they create. They have a loop where they count from 0 up through 7, and they do a malloc of size 128, copying into that malloc congrats your flag is, and the malloc string that they read out of the file, the flag string they read out of the file. Then they also have this random string, sorry, this is not what you're looking for or whatever, and they allocate that, again, the size of 128. They're then going to free flag malloc string, which is the last one of these they malloced. They free random string malloc, which is this other one. Then they come down here, they're going to get to edit 1 byte in the program, and only 1 byte. Then they take address to change and they add it to the very first malloc you did. So we're going to need to think about the very first malloc that we did. We get to set some offset of that and change it to whatever value we want. And it's going to do another malloc. And it's going to print out that malloc plus 16. And the reason it's going to do that plus 16, this is a bit contrived and helping us out. The beginning of a malloc chunk is data about malloc, and the string will be later. And you'll note that they've got that congrats your flag is, which gives us enough text so that when we skip over 16 bytes, we can still print the flag. All right, so that's all very handy. And we can now look here, and we'll actually run this thing. And I've downloaded a copy of GEF, the GDB Enhanced Features. This is going to make the GDB experience a little bit more pleasant for us for attacking. All right, so we'll do a break in main, run the program. You can see it prints out nicely where we are, a little bit about the stack. We can see the registers, etc. And let's set some breakpoints. We'll do a break in malloc. And then I'll continue. All right, so we can see now we're in fopen, we're in fgetS. We're now in our first malloc from main. And we can see that it returned 6034A0. So that's the first address that we have malloced. We can say something like heap bins. That'll show us our bins and heap chunks. So here is our first chunk that we have allocated. We can continue. Let's just continue a few times. And you'll see here we're allocating these chunks that all have that congrats your flag is in them. All right, here is the one that's not helpful, right? This won't help you. Okay, so we keep going. It's going to ask us what byte we want to do. So I'll just say 0, 0. Now we're at the malloc again. And we see that we have these TCACHE bins. We have these TCACHE bins. Here's 603.890, 603.800. So this is the one. 603.890 is the one that doesn't help us. It's been deallocated. This won't help you. But 603.800 does have what we want. Right? So 603.800, we have the congrats here flag is. And of course, again, those first bytes of that has been overwritten when we did the free. So really the issue is that the next time we do a malloc, if we look, it's done this free of these two. We get to edit one byte of the program, and then we're going to get to malloc once before it prints it out. So what we really want is there's this pointer that's going to point to 603.890, and we'd really like it to point to 603.800. So I'll say I'm going to search for something that points to 603.890. And I see that there is a pointer in the heap at 602.088. Right? So if I could change 602.088 to point to 602.0, I'm sorry, 602.088 points at 603.890. If I could change it to 603.800, I would win. So I need to change the memory at 602.088. So that's the address I want to change. And then I just want to change this 90 to be a 0. Now I can't tell it 602.088. What I have to tell it instead is an offset from the very first malloc. Now what was that first malloc? That first malloc, way back in the day, actually I can probably just do it this way. Heap bins chunks. That first malloc was at 602.490. This was the first one. Actually, no, it should be 603.04A0, right? That's where I loaded the flag. So here's my first one, 603.4A0. So I want 603.4A0. Let's be in hexadecimal. 603.4A0 minus, and I said it was at 602.088. 602.088 equals, that's 5,144. Right, so I'm pushing backwards, so negative 5,144, and I want to change that byte to be 0. Okay, so I'll say echo negative 5144. And so I want that. I'm going to have that 0 byte. I'm going to send that 0 byte. I'm going to pipe that to netcat on my port number. And that gives me my flag. So let's review what we did here. So we looked at our TCACHE. We saw that we had a TCACHE pointer. The pointer in the beginning of the TCACHE was at 602.088. We got to modify that. So instead of pointing at 603.890, it instead pointed at 603.800 by changing that 1 byte 90 to 00. We had to do that based on an offset from our first memory allocation. Right? Our first memory allocation was at 603.4A0. So 602 088 was 5014 bytes backwards from 603480. So I sent negative 5144, go that far backwards, the 0 byte, then it changed that byte to a 0. When the malloc happened then, it malloced the one that had the flag in it and printed it out. So we got our flag, picoCTF, and a bunch of random hex.